Alright, this is the video lesson for solving systems of equations using substitution. And we're going to start out here with the definition of substitution. Substitution gives an exact solution by replacing variables. And what you need to know is that you need to have a variable all by itself in order to substitute. So you need to have a variable all by itself in order to substitute. So let's look at an example 1 here. And we're going to start out example 1 by doing this the old way. The old way meaning by graphing it. So in the first equation I have x equals 2y, and I would have to solve this for y, so I would divide by 2, giving me 1/2 x equals y, or we all know that we can flip that and say y equals 1/2. So with my red equation here, I would start at 0, up 1, right 2, up 1, right 2, up 1, right 2, or down 1, left 2, down 1, left 2, down 1, left 2. So my first line looks like that. My second line, which I'll do here in blue, I would first start by subtracting 4x. This gives me 2y equals negative 4x plus 15. And then I would divide by 2, giving me y equals negative 2x plus 15 over 2. And we know that 15 over 2 is the same as 7.5. So here's my blue line. Now, one of the reasons we don't like this is because we don't like starting at 7.5, which in this case would be right here, because it's not perfectly accurate. But anyhow, we'll start at 7.5 for now, go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. So our second line is looking like this. And again, we're pretty sure but slightly unsure. Looks like our line crosses right here at 3, 1.5. But again, we can't be 100% sure because we're not right on a grid mark. But we're going to assume that that's 3, 1.5. So now what we're going to do is we're going to do the same exact problem, but we're going to do it using substitution. So I'm going to go ahead and erase this. Again, I'm going to write my answer up here in red that we got 3, 1.5 is what we think the answer for number 1 is. So let's redo this problem using substitution. Now, when you use substitution, you simply look at your two equations and you say, okay, first of all, like I have up here in starred, I need to have a variable all by itself in order to do substitution. And in this case I do. I have x all by itself. X equals 2y. So as long as you have a variable all by itself, you can take what it equals. So in this case, x equals 2y, and I'm going to plug that 2y in for x in the other equation. Again, because this says x is equal to 2y, I now can replace my x with 2y. So my second equation now reads 4 times 2y plus 2y equals 15. And now I just solve. 4 times 2y is 8y plus 2y equals 15. 8y plus 2y is 10y equals 15. Last step is to divide by 10, so I get y equals 15 over 10, which we know 15 over 10 reduces to 3 over 2, which we know 3 over 2 is 1.5. So we did get 1.5 for our y, which is good because that's what we got the other way we did the problem. So we got 1.5 for y, and now I'm going to take that 1.5, and what you do is now that you know one of the answers, you can plug this back into the other equation. Actually, you can plug this back into either equation because it's now a number, right? So I'm going to take this 1.5 that I know y is, and I'm going to plug it into either the first equation or the second equation for y. In this case, I'm going to pick the first equation because that's going to be the most easy, and I'm going to say x equals 2 times 1.5, and 2 times 1.5 is 3. So again, I got my two answers here of 1.5 and 3, and again you always write x comma y, so that's going to be 3 comma 1.5, and so we see that that gives us the exact answer we got when we graphed without having to do the graphing. So this is substitution. This is how you do substitution. I'm going to do the next problem for you, and then I want you to try the last two on your own. Next problem here, number 2. Again, we do have a variable all by itself. We have y is equal to 3x minus 8. Now notice I've been putting what the variable equals in parentheses because then I'm going to replace that parentheses into the other equation. So since y is equal to 3x plus 8, I'm going to rewrite 3x plus 8 in the next equation instead of writing y. So, or sorry, not plus 8, but minus 8. 3x minus 8. It goes in place of this. Then we have our equal sign, and then we have 4 minus x. So again, I've just simply rewritten that second equation by plugging 3x minus 8 in place of y. So instead of y equals 4 minus x, it's 3x minus 8 equals 4 minus x. And now we go about the solving process here. So to solve this one, I would probably add x to both sides. That's going to give me 4x minus 8 equals 4. I would then add 8 to both sides. 4x equals 12. Last step, divide by 4. X equals 3. Now remember, that's only part of your answer. That's the part of your answer that's going to tell you that this system of equations has one solution, and that solution is going to be 3 comma whatever y is, and we figure out y now by taking this x of 3 and plugging it into either of these two equations. I'm going to pick the bottom equation this time, so I'm going to say y equals 4 minus, and instead of 4 minus x, I'm going to say 4 minus 3. So y equals 1, so that's what goes into my ordered pair. So again, this is your solution. This system of equations has one solution. It's going to cross the two lines if we were to graph this, which we're not graphing it right now, but if we were to graph the two lines, they would cross at 3 comma 1 would be the ordered pair that they cross at. And we got that without graphing by just solving it algebraically. So there you go. I changed my mind. I'm going to go ahead and show you number 3, and then I'm going to let you try number 4. Excuse me. I'm going to let you try number 4 on your own. And this is because in number 3, we do have to do something slightly different, and that is that neither of these equations have been solved for a single variable. And if you remember our rule on the top, you need to get a variable all by itself. So I look at these two equations, and I notice that, hey, this x is 1x. So that should be pretty easy to get all by itself. And I'm going to do that by adding 1 to both sides, and turns this equation into x equals negative 4y plus 1. So I'm going to go ahead and just mark this equation out because I've changed my second equation into this, x equals negative 4y plus 1. I'm then going to put what x is equal to, and x is equal to the negative 4y plus 1. I'm going to plug that into my other equation in place of x. So my other equation now says 2 times negative 4y plus 1 plus 7y equals 3. Now again, notice here how I definitely put this in parentheses for a reason, because you had in the first equation here, you had you had 2 times x, but now we don't have 2 times x because we've replaced the x with that negative 4y plus 1, so now it's a distributing problem. You have 2 times the quantity, negative 4y plus 1, and then you still have the plus 7y and the equals 3. So we'll go ahead and solve now. Again, it is distributing now, so I'm going to distribute the 2, and I'm going to get negative 8y plus 2 plus 7y equals 3. Again, keep track of what sides of the equation you're on. On the left side of the equation, I have a negative 8 and a positive 7. That just combines, like terms, negative 1y plus 2 equals 3. Now I can continue to solve. Subtract 2 on both sides. Negative 1y equals 1. Divide by negative 1. Y equals negative 1. So my y is negative 1. Again, telling me right away that these two problems are going to have one solution, and the one solution is going to be something comma negative 1, because my y is negative 1. I figure out what my x is by plugging this negative 1 back into an equation. I'm going to pick the bottom equation this time because it looks easiest. I'm going to say x equals negative 4 times negative 1 plus 1, which is then x equals 4 plus 1, x equals 5. So final answer here is one solution, and the one solution is 5 comma negative 1. Again, that means that is where the two lines, if you were to graph them, the two lines would cross at 5, negative 1 on the xy axis. Okay, I do want you to go ahead and try the fourth problem on your own. I will give you a hint here, though. This is a trick. There is something special about this problem, but the way you work this, the way you start this problem is the same. So go ahead and pause and try this on your own. Alright, and we're back. First thing you're going to need to do is solve one of these equations for a single variable. Again, since this second equation has a 1y, that's going to be the easiest to solve for because I just have to add 3x to both sides. So I'm going to get y equals 2 plus 3x, and I'm going to mark this out. I don't need that equation anymore. Notice I didn't write this in slope-intercept form, and that's because I'm not graphing, so I don't necessarily need slope-intercept form. I just need to have one variable solved all by itself, and I did that with the y. So now I can say, well, since y is equal to this binomial, or this quantity right here, this 2 plus 3x, I can plug this 2 plus 3x. I can plug this 2 plus 3x in for my y. So I'm going to rewrite that first equation, and it's now going to say 6x minus 2 times, but instead of y, I'm plugging this in there. So it's 2 times 2 plus 3x, and then that equals negative 4. So now I can go about solving. So 6x, I'm going to distribute my negative 2. That's going to give me negative 4. it's going to give me a negative 6x, and it still equals negative 4. And now, this is where you notice the special part of this problem. On the left side here, I have a positive 6 and a negative 6. Well, those make 0. So what happens is my negative 4 comes down. My negative 4 comes down. My equal sign comes down, and this negative 4 comes down, and I end up with this, negative 4 equals negative 4. Since that is a true statement, you know that this problem has infinitely many solutions, which I've told you guys you can abbreviate just IMS. And again, you got to remember what IMS means, what infinitely many solutions means. It means that these two equations that we started out with here are the same exact line, so they're right on top of each other. Now, another thing to understand is that if you would have gotten a false statement over here, if you would have had something like negative 4 equals 7, and that was false, what does a false statement mean? That means no solution. So that's what happens when all your variables cancel out. You either get an infinitely many solution because it's true, or you get no solutions because the statement's false. And then you know about your lines. Remember, infinitely many solutions means that it's the same line right on top of itself. No solution means that you have parallel lines. So, again, those are some things to remember, that we're doing the same thing we did in the graphing section. We're just not having to graph the problems anymore. All right, so go ahead and try assignment 1 now in your packet.